Let's talk about our rotary encoder. It's got three terminals, A, C in the center, and B. And they just have A has a ring of contacts on there, and B is another ring of contacts here. They're placed 90 degrees apart. So when we're turning the encoder in the clockwise direction, A is engaged first, then B, then A, then B. So we have A, then B, then A, then B, and we know we're going clockwise direction. If we're going counterclockwise, the sweeper is going to come in contact with B first, then A, then B, then A. So we're going to go B, then A, and B and A. We know we're going counterclockwise. So what we're going to do is we're going to use it as a counter. In the clockwise position, we're going to add, and in the counterclockwise position, we're going to subtract. Now, whenever you have a contact closures like this, these contacts can bounce and give you false readings. So we're going to use a Schmidt trigger to eliminate the bounce on there. Here it is here, and there's a 10K resistor here, and we put our 5 volts on here. And so we get 5 volts out on pin 1 on our Schmidt trigger here. You could actually eliminate the Schmidt trigger and just go directly to your I/O at this point. But we have the Schmidt trigger in here. It's got some hysteresis in there. It'll help us out. So we get 5 volts on here. When the contact closes, it goes to ground, and it eliminates the voltage over here. So now we have a capacitor across the contacts, and this happens to be a 104. And these are in picofarads. So what that means is that there's a 10 with 4 zeros after it, so it's 10,000 picofarads. Now if you move the decimal 3 places to the left, you get 10 nanofarads, and if you move it another 3 places to the left, you get 0.01 microfarads. So the time constant is only going to be 1 millisecond. Now if I was using just regular push buttons, I usually use a 10 microfarad capacitor so that the time delay is a lot longer. But I thought that we can be able to spin this thing pretty fast, so I didn't want the time delay to interfere with our count. So this is the setup I'm using to debounce it, and it seems to work pretty good. I'm using an Arduino Nano, and here it is here. Here's the encoder, and if we turn it clockwise, it starts to count. And I can turn it fairly fast here. And as you turn it counterclockwise, it's subtracting the numbers, even down into the negative here like that. So that's our rotary encoder. This is the program that I use. I use the Adafruit library for the LED display, and it's pretty straightforward. I'll put it down in the comments, and I'll make sure I comment all the lines in there so you see what it looks like. But anyway, that's a rotary encoder. Thank you.